Hello everyone, my name is Alexander Dunaev and this is Data Zen Community. And today we have one more talk about AI. Our speaker is Andrei Semeniuk, a machine learning engineer from EPAM Systems. And today's talk relates to RAG, LLM, NLP, but probably you already heard about these buzzwords. But today is a new opportunity for you to learn something new. So Andrei, floor is yours.
Thank you so much, Alexander. Yeah, hi everyone. Today I want to talk about some optimization techniques in RAG. Let's talk a bit about myself. I work as a tech lead machine learning engineer in EPAM system. I'm focusing on building GenAI project from the ground up for clients in the US and Europe. My experience lie in improve RAG pipelines, designing ontologies, and evaluating model performance to make AI solution more reliable and efficient. Before that, I spent years developing data-intensive system with Spark and Databricks, as well as building scalable microservices in Java and Scala industries for like banking, IoT, and security. Okay, let's begin. I know a lot of people have used ChatGPT or Cloudy. We have accessed it on the web. Essentially, it's a service you can use online. You type a question into it, it provides an answer. It's simply chat based on LLM like ChatGPT for providing questions and answers. But on these applications, you will have not your personal documentation and data. And large language model can provide only common knowledge. The next step of using LLM is creating a GenAI application, which uses prompts and responses for step-by-step execution. What is a RAG itself, and what is a problem itself? Traditional text generation models like GPT-4 or 5 have impressive capability, but they come with significant limitation. One of their main drawbacks in their reliance on fixed knowledge, which makes them less effective when answering queries that require up-to-date information. These models cannot update in real time or access external database, which compromises the accuracy and relevance of their responses. In a world where the data quickly becomes outdated, a more flexible and powerful solution is needed. Where with the RAG come into play? Combination information retrieving from external sources with text generation. With RAG, we can significantly improve the quality and relevance of answers to even the most complex queries. But one of this kind of GenAI application is RAG. RAG is an approach where neural network generates answers using not only internal knowledge, but also external documents. The system first retrieves relevant data from a knowledge base, retrieval, and then inject this information into the model prompt generation. This method enables updating AI knowledge without retraining the model. For example, it can connect to corporate documents, client knowledge bases, or other external document data sources. As a result, the response becomes more accurate and up-to-date. The basic RAG pipelines look simple. We take a query, retrieve document from a vector store, and feed them into LLM. But in practice, this approach often yields weak results. First, retrieval can return dozens of irrelevant documents, and the model starts to hallucinate. Second, each query to the vector index is expensive in terms of time and resources, especially with large collections. Finally, the LLM wasted tokens on garbage documents, which increases cost and reduces quality. That's why we need additional layers of optimization for RAG. And the issue with standard RAG is that its component works as is, without context awareness or prioritization. Retrieve searches too broadly, not knowing what actually important for the answers. There is no caching, so the same queries get processed over and over again. The model doesn't understand business rules of user-specific constraints, so it gives answers that are generally on topic but not accurate. Without extra optimization, RAG quickly becomes an expensive and efficient tool. That's why techniques like Reranking, Semantic Caching, Metadata Filtering, and query planning have emerged. And today we're talking about it. Reranker is a tool that allows you to reconsider the initial list of results and make it as useful as possible for the user. This process is similar how to pick the ripest fruits from a basket, but with the help of advanced algorithms. The method involves collecting signals such as semantic similarity, query context, and user preference, and then applying model to create the perfect ranking. Reranking is actively used in search engines, recommendation services, and generative models. For data scientists and software engineer specialists, this process opens up opportunity to improve system accuracy and better understand user needs. In other words, reranking is the art of making a good result great. What exactly reranking step by step? How the ranker system work? First, at the first stage, the most relevant documents or chunks are selected based on the query using embeddings. For example, we're taking top 25 most relevant results are retrieved. Second, next, the reranker mechanism evaluates the quality of retrieved documents and reorder them based on the relevance. As a result, only top 3 most relevant documents are selected, which best match the query and can be used for the final response. This approach significantly improves search accuracy and enhances the quality of the provided information. What is the main stages of the reranker? Reranker is a structured process that starts with extracting the initial selection, again, for example, top N candidates, using method methods like such BM25 or neural models. The second stage is the collection of additional signals, what it can be, semantic similarity, user history, metadata, and even temporal factors. Then complex models analyze these candidates, assessing their relevance to the user query. The final step is reordering the results to the present to the user with a list with the best matches their expectations. The stages of reranking resemble the work of the chief. First, the ingredients are selected, then the quality is carefully checked, and only after that the culinary masterpiece is created. What is the methods in reranking itself? Reranking methods differ in how they evaluate and rank candidates. The point-wise approach considers each item in the list separately, assessing its relevance independently of others. In our case, the pairwise method compares of candidates to determine which one better matches the query. And final ways method is listwise. Method optimizes the entire list as a whole using complex loss function to account for interrelationship between candidates. Each method has their own advantages. Pointwise is simple and fast. Pairwise are more accurate for comparison, and listwise is most powerful, but of course requires significant computational resources. The choice of approach depends on the task, ranging from quick searches to complex recommendation systems. Also, reranking choosing by models. Reranker today actively leverages the power of modern machine learning models, especially transformers. For example, cross-encoders analyze the query and document simultaneously, providing maximum accuracy, but required more computation time. In contrast, for example, B encoder separates the process of the query and the document, making them faster but less precise. Again, this is based on the task what you're solving. This model, such as a BERT and GPT, can capture complex semantic relationships that were previously unreachable for traditional approaches. What is the real application of reranking? Reranking is used in numerous real-world scenarios to improve search and recommendation quality. In search engines like Google and Bing, reranking helps select the most relevant pages from millions of candidates. In recommendation systems such as Netflix or Amazon, it's account for user preference to suggest movies or products what will genuinely interest the user. In e-commerce, also heavily relies on Reranker to enhance buyer experience, for example, helping them find needed products more quickly. In scientific system and analytics, it assists in seeking relevant research or data amount vast amounts of information. By applying complex models and signals, such as interaction history, metadata, and query context, Reranker personalizes the result. This not only improves the user experience, but also boosts conversation rates and customer loyalty. Okay, let's check one example. For example, we want to find best restaurants in Milan. I think now it's a good weather there. At first stage, we just basic search return top 50 restaurants, selected based on the simple criteria, like, for example, popularity and number of reviews. It's also good, why not? Second step, additional factors are analyzed. For example, ratings, user reviews, type of cuisine, location, and geolocation from the user. For example, it might be essential for the restaurant to be near a specific landmark. And step 3, Reranker algorithms are applied to reorder the list which was ordered before, considering all these factors and offer the most relevant results tailored to the user query. Outcome, we get a list of restaurants that precisely matches the request, considering not only popularity but also other nuances, such approximate to specific place or cuisine features. What is another example on Reranker? Reranking is used in search engines, chatbots, and financial assistance. For example, in e-commerce, it helps show relevant products instead of random junk. In medicine, it selects articles related to a specific diagnosis rather than general notes. Best practice includes hybrid search, for example, semantic caching and fine-tuning models for the domain. The main rule, of course, always test on real data and don't rely on default setting because it will be anyway waste. What next? Of course, despite all its advantages, the Reranking process faces several challenges and limitations. One of them, a high computational load. Of course, it's taking some time. Modern models, such as transformers, require significant resources for training and implementation, which can be a problem for scalable system. Additionally, signals for Reranker must be carefully choosing to avoid overfitting of using excessive information. Misusing data or insufficient integration with basic methods can degrade result quality. Another challenge is balancing between accuracy and speed. For some applications, such as real-time ones, response time is critical, and complex model may not to be suitable here. What are the tools you can use for Reranker? For example, Reranker models improve search accuracy by reordering retrieval document based on semantic relevance. Popular solutions including Colbert, Monet5, and cross-encoded BERT, for example, which strike a balance between speed and quality, as we talked before. Training and integration are often done using Hugging Face, Transformers, and PyTorch, while TouchServe is commonly used in production scenarios. Integration into RAG pipelines is streamlined through tools like Llama Index and LangChain, enabling flexible architecture. Capability with dense retrieval systems like FAIS, Milvus, VV8 make it possible to scale across large documents collection, again, if you need. In the cloud, of course, have also this interpreter of Reranker tools. Major cloud provides offer out-of-box services to support Reranking approach. AWS provide integration with Amazon Kendra, and custom models support via SageMaker enable flexible search solution. Google Cloud offers Vertex AI, TensorFlow serving, and access to models from the Model Garden, which can be used for Reranking tasks. Azure AI Search allows integration of custom Rerankers built with Azure ML, along with support for OpenAI embeddings. This solution helps companies accelerate RAG system deployment without building everything from the scratch in a very, very quick manner. Another tools for optimization in Reranker is Colbert. What is a Colbert? Colbert is one of the most popular neural Reranker. It breaks text into tokens and uses dense embeddings to compare at the phrase level, not just the whole document. In RAG, it works well with dense retrieval, where candidates are first found by vector similarity. Colbert helps filter out the noise and keep only documents truly relevant to the query. This greatly improves the quality of LLM responses, especially in complex domains like finance or medicine. Another small example for boosting RAG performance with Colbert. In one project, Colbert was implemented to optimize search in financial documents. Before that, users complained about noisy LLM responses. After adding Colbert, the number of relevant documents in the top 10 nearly doubled. This reduced the model's hallucination and increased user trust. Colbert demonstrates that reranking provides a measurable impact, at least in this case. Also, of course, Llama indices also can be used for improved search relevance. Llama index is a convenient framework that helps build custom RAG pipelines. It easily integrates Reranker at the search stage and allows combining multiple retrieval strategies. For example, you can use hybrid search, BM25 plus dense vectors, and then apply the Reranker for fine filtering. It's just possibility for any future improvements. Llama Index also supports working with Colbert and other neural models. What is the understanding inside how Reranker work? The main strain of modern Reranking and their ability to understand meaning, not just keywords. LLM models can take into account the query context, synonyms, and even hidden user intents. For example, for the query best voice to hedge currency risk, traditional search might return random articles about currency, while the Reranker highlighting exactly the content about hedging risk or hedging anything. Semantic understanding is especially important for long or complex queries. This transforms search into a dialogue rather than a mechanism document retrieval. It's more about thinking. Basic Reranker are good, but very advanced tricks which can be useful if you will be implemented. For example, multi-stage Reranking, where a fast filtering is used first, followed by a more expensive model, for example. For example, multi-stage Reranking, where a fast filter is used first, followed by a more complex, expensive model, or combining cross-encoder and B-encoder to balance speed and quality. User context, user history, and even reinforcement learning can be incorporated. These techniques help tailor the system to specific domains and workloads. Of course, not forget about metrics. Metrics very significantly important. Evaluating the quality of Reranker isn't just about precision and recall. There are more nuanced metrics like NDCG, normalized discounted cumulative gain, and MRR, meaning reciprocal rank. It's also important to measure latency, since reranking can slow down the pipeline. And a good reranker balances speed and accuracy. In real-world system, metrics should be linked to business outcomes, clicks, retention, and answer quality. It's most important. The future of trends of reranker and search precision. The future belongs to models that handle multimodal data. Text, charts, images. The idea of self-reranker is gaining traction, where the LLM itself can verify and reorder documents. Adaptive reranker, which adjusts to user behavior, will become increasingly important. We can expect the emergence of zero-latency reranker, where models are so fast they are virtually unnoticeable in the pipeline. All of this lead to search that closely mimics human reasoning. The future of Reranker involves developing more flexible and faster model capability to adapting of changing inquiries and data. One trend is using online learning, where the system continues to adapt in real time, learning from new data without needing a full retraining. Such approach enhances the efficiency and accuracy of re-ranking while reducing response time. Additionally, the implementation of multitasking model that can work with multiple sources or signals simultaneously improves quality and personalization. The future of re-ranking will also involve deep use of emotional and context signals. Just imagine allow for even fine understanding the user mood and intent. Moreover, with advanced in reinforcement learning and other advanced methods, re-ranking will become more adaptive to real-time processing and capable of managing even the most dynamic and noisy data. This opens up new horizons for application in chatbots, recommendation system, and even next generation search engine. But of course, what is the common pitfalls? I mean, well, if you will be implement some re-ranker, common mistakes including, for example, overloading the pipeline with too heavy model, neglecting cache updates, and ignoring business metrics. Another issue is trusting the models without testing it on real data. Sometimes re-ranker processing results in the initial retrieves is too weak. To avoid this, carefully balance retrieve and re-ranker stages. Most important, implement quality monitoring in production, not just in the lab. Okay, let's move forward. And next optimization method for RAC is semantic caching. What is that? Semantic caching is an advanced technology that speeds up query processing and improves performance in system using RAC. Instead of repeatedly performing the same search and generation operation, semantic caching stores not just results but their semantic representation in the cache. This means that a query is similar to one already processed. The system can quickly return the results by passing expensive operation. Such optimization significantly reduced response time and resource consumption. This is especially important in applications where users often ask similar questions or look into related data. By caching embeddings and query results, we can avoid unnecessary work and cut down on latency. As a result, semantic caching helps build faster and more efficient system for processing large volumes of information. This technology is key to create high-speed scalability solution for modern AI-based application. How this work, semantic caching? Semantic caching work by using vector representation of queries, allowing the system to quickly find similar queries and return results from the cache. Instead of storing exact text queries, it can be rich. The system saves their embeddings, which can be compared to new queries based on the semantic similarity. Then a new query arrives, its vector is compared to the stored vectors, and its similarity is high, and the result is retrieved from the cache. This speed-up process science where no need to perform the search or generate answers again and again. If no suitable result is found in the cache, the system executes the new query and adds into the cache for future use. Thus, semantic caching not only speed up query response, but also optimize resources by reducing the load of models and databases. Caching becomes especially useful when queries are frequently repeated or similar. This helps reduce latency and make system more responsible and efficient. What is the main components of semantic caching? The main components of semantic caching include query vectorization, multi-layer caching, and data freshness control. First, queries are transformed into vector embedding. They represent their semantic content, not just the text. These vectors are then stored in the cache, enabling fast retrieval or similar queries and reuse of previously processed result. Multi-layer caching involves use both in-memory and disk-based storage for different types of data. This allows efficient balance between fast access and long-term storage. Data freshness control is very important to ensure cached results remaining up to date. Guarantee that system uses only relevant information. It's also crucial to properly set up the similarity threshold for finding related queries to avoid the pitfall for overbroad caching. All these elements work together to create a fast and efficient query processing system. What are the advantages of semantic caching? Of course, semantic caching offers many advantages that make a crucial part and optimization modern system. First, it significantly speeds up response time. By caching similar queries and results, the system can instantly return answers without performing repeated computation. Second, it reduces the load on computation resource. Reusable results are fetched from the cache, saving API calls, and then no need to generate new data. The third advantage is cost reduction. Every query that can be served from the cache data becomes cheaper to process and more cheaper. Moreover, semantic caching helps improve system performance, ensuring more stable operation under high loads. And it also enhances scalability, allows the system to handle large volumes of query efficiently. What is the drawbacks and challenges of semantic caching? Despite all these advantages, semantic caching has certain drawbacks and challenges. First one of the main obstacles is the need to maintain data freshness. It's difficult. Cached results can become outdated, and if the system does not regularly update or remove all data, it may lead incorrect or stale answers. Second, caching requires additional computational resources to store vector embeddings and process query, which can be a problem for resource-limited systems. Another difficulty is a similarity threshold. It's crucial to finely tune which queries are similar enough to fetch cache data and which ones require a new search. Additionally, managing caching longevity adds complexity. Decision must be made about when to delete data to avoid memory overflow. Finally, configuring caching in distributed system can be challenging due to the complexity of synchronizing multiple cache instances. All these challenges require a careful approach to balance efficiency and accuracy. What is the tools can be used for semantic caching? There are many tools available for implementing semantic caching that simplify the process of storing and searching cache data. One of the most popular solutions is FAIS, a library optimized for fast similarity search over vector data. It's ideal for working with large volume of embeddings and allows finding similar queries with seconds. For storing caching data, Redis and Memcached can be used, offering fast in-memory data access. For more persistent storage, solutions like SQLite or Postgres provide disk-based storage with good performance. If you need to work with more complex vector database, you can use solutions like VV8 or ChromaDB, which provide a higher level of abstraction and additional features for working with vectors. The choice of tools depends on your project, task, and scale. It's also important to consider performance requires, cost and complexity of integration with other parts of the system. In the cloud, semantic caching is enabled by managing services and deep integration with AI stack. AWS offers Elastic Cache for Redis and Memcached, as well Amazon Kendra for intelligent search with semantic caching. Google Cloud provides Scan and Vertex AI matching engine, which enables scale vector search and caching of embedding queries. Azure offers a search which supports for vector indexes and the ability to cache results through integration with Azure Redis Cache. Out of box. This service allows semantic caching to scale under heavy loads and easily embedded into existing RAG pipelines. What can be optimizing for caching or for scalable system? For example, as systems scale, it's crucial to properly configure semantic caching to keep it efficient and fast. In distributed system, it's important to consider how to synchronize cache data across multiple servers or nodes. One approach is data sharding, where the cache is distributing across different nodes depending on the type of query of data. This helps avoid overloading a single node and improves overall system performance. It's also essential to set appropriate time to life, TTL, for cached data so that our data results don't occupy memory unnecessarily. Ensuring horizontal scalability allows the system to handle increasing query volume without losing performance. Using caching strategies that maintain consistency help prevent situations where cached data conflicts with the current information. Optimizing semantic caching for scalable system enables you to manage large data volumes, maintain high-speed performance, and reduce computation cost. Okay, next stage is new optimization method. It's metadata filtering. What is that? Metadata represents data about data. It includes elements such as topics, text, timestamps, authorship, and document formats. These metadata attributes allow the system not just to search for any documents, but to identify the ones are the most relevant to the query. Filtering by metadata improves the quality of retrieved information and reduces time required to process large volumes of data. Think of a RAG system as an expert library who not only knows where every book but can quickly find the best ones based on the preference. As a result, using metadata makes RAG a more efficient tool for solving even the most complex tasks. What are the types we can store inside metadata for filtering, for example? Using different types of metadata for filtering is a key tool for improving accuracy of RAG system. The most common types of metadata including timestamps, which allows you the search to be limited documents created with a specific time frame, especially useful for retrieval up-to-date information. Topic tags help focusing on specific subject areas, excluding irrelevant data like the domain knowledge. Document format, example text, audio, images, enable the RAG system to select the most suitable type of content for processing. Authorship, of course, can help assessing the expertise of the source, increasing the trustworthiness of the results. And of course, language filtering ensures content is retrieved in the required languages, which is especially important for multicultural and multilingual systems. Of course, no problem to translate it later, but in indexing and searching, it's important. Okay, what is the benefits of metadata filtering? For example, using metadata filtering in RAG system offers numerous of advantages, making them significantly more efficient and accurate. First and foremost, metadata helps eliminate irrelevant results and greatly reduce noise. This is especially crucial when working with large volume of data, where precision is a key. Metadata enables the system to focus on truly meaningful information, thereby improving the quality of responses. Additionally, filtering by metadata speeds up data search and processing, which enhances overall system performance. Reduced search time also leads to lower computation costs. It's important factors of large-scale projects. How it works inside? Let's look at one example. And example, for example, how metadata filtering is using in RAG system. Imagine we receive the query, how does climate changing affects bird migration? To provide an accurate and up-to-date answer, the RAG system applies metadata filtering. First, we limit the search to scientific articles published with the 5 last years to ensure data relevance. Then, we apply topics tags like climate changing and bird migration to narrow the document pool to only those related to the specific subject. Additionally, we can filter in by language, excluding non-relevant languages, and keeps only English publication, for example. As a result, RAG system quickly and accurately retrieve necessary information. It's very speed up the process. And if talking about tools for metadata filtering, metadata filtering improves search accuracy by narrowing results based on additional attributes such as date, after, source, or business rules. Modern vector database provide you like Pinecone, VV8, Milvus, and Chroma support metadata level filtering and index level. For hybrid search in combination of traditional methods like BM25, Elasticsearch, OpenSearch, and dense retrieval is used. This approach allows for both exact matches and semantic relevance. It's especially important in enterprise scenarios where strict required are placed on information sources. Filtering helps reduce noise and decrease the load of LLM during generation. Okay, in the cloud solution, metadata filtering built into managed search services as vector database. AWS offer open search services and integration with Canvas for hybrid search that incorporate business attributes. Google Cloud provides Vertex AI, matching engine, and BigQuery vector search, which support metadata filtering for analytics queries. Azure AI Search includes vector index and advanced filtering for enterprise use cases. These services allow quick implementation for metadata filtering without complex infrastructure setup. Okay, and one of the most interesting stuff is final optimization method. This is query planning and chain of thoughts. What is that? Chain of thoughts is then it's come to Retrieval-Augmented Generation, RAG. The importance of proper query planning and structured thoughts cannot be overstated. This is a key element that enabled language models to efficiently retrieve and integrate data from external sources, such as database or search engines. Query planning helps precisely determine which queries need to be sent to get the most relevant data, while chain of thoughts organize this data into logical sequence, ensuring clarity and accuracy in generating responses. Together, these two approaches significantly enhance the quality of models. Their ability to think through problems and correctly use information. It's important to remember that in the world of RAG, there is no room for random queries and chaotic thinking. Every action has a purpose and logic. What is the query planning itself? Query planning is both an art and science of how properly formulate queries to extract the most relevant information from external data sources. It's not just about sending a query to a search engine, but a whole process that includes analyzing its needs to be found, which data is important, and how best to retrieve it. In the context of the RAG, proper query planning helps minimize redundancy and obtain precise answers, significantly improving the model performance. A well-planned query directs the models down right path, ensuring effective information retrieval that will be useful for further generation. It's like creating a roadmap. For more accurate the plan, the faster and more efficient you reach the goal. However, even in the world of machine learning, the perfect query can be complex and may require several iterations. After all, if it were that simple, we would generate perfect answers on the first try. But with every right step, we got closer to the ideal result. Okay, what is the key task of query planning in the RAG? The main goal of query planning is ensure accuracy and efficiency when retrieving data. To achieve these, several key tasks must be addressed. The first task is identifying relevant data source. For the query to be successful, it's important to understand where to get the information from, whatever its databases, document, or external APIs. The next step is query optimization. I mean, it's minimizing unnecessary data and obtain only what is truly important for solving the task. Additionally, considering the context of the query is crucial. At the time, and the same information might be useful is one context, but irrelevant on another. Context is important. Another important task is coordinating multiple queries. Sometimes to get a complete answer, several queries need to be sent, which can be processed either in parallel or sequential. These tasks help improve not only the accuracy, but also the speed of data retrieval, which is critical of the successful operation of complex RAG system. Again, we're talking about some production-ready solution. And how does chain of thoughts work? This is our second step. Chain of thoughts is a methodology that helps models develop reasoning step by step. Instead of jumping straight to the answer, the model processing information sequentially, making intermediate conclusion on each stages. It's like a solving puzzle. First, you figure out the piece, then gradually move to the next. Chain of thoughts helps models not only gather data, but also build logical structure for using it, which is especially important when tackling complex problems. This approach ensuring clarity and consistency in the answer generation process. With chain of thoughts, the model can make more grounded and contextualized inference, improving the quality of the final response. It's important to note that having a clear chain of reasoning enables a model to correctly interpret and use information, even if data is limited or incomplete. Therefore, using chain of thoughts in RAG helps models think more human-like in their reasoning. And what is the stage for processing consisting for chain of thoughts? Chain of thoughts process consists of several key stages, what help models logical and sequentially move toward to correct answer. The first step is task decomposition, where a complex problem is broken down into small, simpler, manageable parts. It's like solving a complex puzzle in first understanding the individual pieces before putting the whole picture together. The next stage is formulating reasoning steps, where the model builds the answer based on the information gathered. These steps help establish a logical structure and avoid mistakes. And the first stage, the system uses an intermediate conclusion of the further refine the solution instead of jumping straight on final answer. Finally, last stage, the model integrates all governing information to produce the final response. This process ensures that each step is logical and based on clear sequential reasoning, step by step. Okay, what inside technology can use that? Query planning helps to break down complex user question into subtasks and select the optimal data sources. The LangChain and LangGraph ecosystem support query planning and orchestration of calls chains. Llama Index query engine can plan queries across multiple data sources. And reasoning capability models such as GPT-5 or Cloudy can use chain of thoughts out of box. For complex pipelines, of course, in production, for example, you can use orchestration like Airflow, Prefect, or Duckster, and use it manageable task evaluation. In the cloud, query planning and chain of thoughts are integrated into AI platforms built for working with LLMs. In AWS, Step Function can be used for that, alongside Bedrock to manage query chain for reasoning. Google Vertex AI includes built-in orchestration and supports the tool-former approach for dynamically selecting data source. Azure offers logic apps and AI services orchestration to manage chains and complex queries. These solutions simplify development by abstract away infrastructure complexity. Okay, how do query planning and chain of thoughts answer generation? Query planning and chain of thoughts work together to significantly improve quality of generation answer in RAG. Query planning helps precise formulate queries, which ensure retrieves of most relevant data. However, once the data is retrieved, it's crucial that the correct interpreter and structure it. That's where chain of thoughts come in. Together, where approaches allow the model not only to gather necessary information, but also to process it logically step by step, building a coherent process it logically. This is especially critical for complex tasks that require more than just a fact. They demand a thoughtful integration of multiple data points. Chain of thoughts helps connecting various information sources and ensure they interact correctly. This enabling the generation of answers which were not only accurate but also logical justified. Ultimately, combining effective queries planning with coherent reasoning makes the system much more efficient and useful. And external data is central role in improving data quality and accuracy of answer in the RAG for any optimization method what we're talking today. Models are not limited to what they know internally, but can access vast amount of information to enrich their responses. Proper integration of this data required access, efficient query planning, and chain of thoughts structure. External sources such as database, documents, or web resources enable models to better understand the context and provide more precise and good detailed answers. However, working with external data involves not only correct retrieval, but also efficient processing and utilization within the query framework. Thanks to well-planning queries and sequential reasoning, data from external source become not just additional to the response, but its foundation. This allows models not only generate answers, but also to build them thoughtfully based on the current and relevant information step by step. What is the benefits combination of chain of thoughts and query planning? Combination of these provides significant advantages in the process of retrieving and processing information with RAG. Firstly, it improves accuracy. Each query is carefully designed and the chain of thoughts helps processing data in a logical sequences. Secondly, this combination greatly speed up answer generation of minimized time spent on data retrieval and processing. Proper query structure and logical reasoning make the model more flexible and adaptive to different types of tasks. Additionally, using chain of thoughts promotes deeper data analysis, allowing for conclusion that requiring not just knowledge but understanding in the context of specific situation. It also helps avoid errors and distortion in answer. In each step, the reasoning process is checked and corrected. As a result, this method contributes to creating more intellectual and reliable systems. In the long term, this enhances efficiency and scalability of models, making them easy to adapt to new data and tasks. Okay, that's it about optimization method in the RAG system. What is the next step wave of RAG optimization? We'll be focusing on adaptive and autonomous techniques. We'll see dynamic query planning, smarter semantic caching, and hybrid search that blends symbolic reasoning and vector retrieval. Cloud and open source ecosystem are rapidly integrated their capability, making them easy to adopt. Over time, RAG will evolve into agent system anyway that not only retrieve but also plan, reason, and refine knowledge in real time. Yeah, I prepare some useful links that suggest Databricks documentation. It's very useful. Good cookbook from OpenAI. Information about chain of thoughts from Prompt Guide and the good documentation from Mastery AI. Thank you. Any question, Alexander?
Yeah, thank you, Andrei, for your interesting presentation. Yeah, let's move to questions. We have them several. Yes, the first question, what if we use all additional information not for the re-ranking stage, but for the initial ranking?
Yeah, it's possible. Here, additional stage, how it will be using step by step. I mean, about if you put a lot of information on the initial stage, it can be more noisy itself. But if you're making this for different kind of, for example, like filtering, firstly you're making some one type of filtering or conclusion, some the ranking, and another types you're making for re-ranking another stage and another filtering, and also you can use another model. It will be more efficient. Here, not most important how much data you're using. Here, much important what filtering inside you're using it for making best results on the final. And again, it's like from performance stage and for some production site what we developed before.
Okay, got it. How to measure and optimize the relevance of the response to the user query?
It's very, very good question. In production, I'm working a lot with that. Anyway, we mostly working with golden set. We have no in our choice. We provide some golden sets, 1, 2, 3 golden set with expert and making this correct question, correct answer. And after that, measurable all chunks, which was retrieval. We including some latency, we including time calling to some database, for example, if we're making some Redis or any other embeddings, we calling how much time to LLM, and all these metrics help to this. But anyway, in real production cases, because LLM can compare the answers, correct answers, what it will be, but it can prepare for you golden set, but it not can be like expert what exactly needed in your area. So that case, in production, in real life, golden set is good way, and metrics you can just made it manually. After that, put all these metrics like Sentry or some Grafana and got very, very good charts. It looks very pretty good.
Yeah, there is one more related question. Are there situations where performance optimization and quality optimization conflict? Maybe how do you, like, maybe based on your experience, and how do you choose?
Yeah, all these methods which I'm talking today, this is about optimization. I mean, about balance between some efficient and time consuming, because again, some timing can be making very, very good result, but spend a lot of time. And another can be quickly making the result, but not a very good precision. In real life, yes, we have, and from real production experience, I can suggest not to using complex solution. If you not needed using Reranker or keyword generation, not using it. Again, keep it simple, stupid. I mean about make it the same tools which is needed in your site, because anyway, searching, embedding in Redis still quickly. It can be help you to find this chunk. Just try to simplest way, and after that, making more complex tools.
We have one more very practical question. Agentic rec, like self-rec, corrective rec, adaptive rec, have stages where irrelevant documents are filtered out. How do they compare with re-ranking methods?
This can be possible for a combination of these. I mean, about Reranker, it's like a tool. You can add it for some your in the beginning stage, on the middle stage, not big deal. And you compare this with another technique. In our case, we're not using exactly this, but we comparing some keyword generation and this very good making this combination semantic search and these methods which I'm talking today. I mean, I have no practical answering for this, but you can not afraid to play this for background. Anyway, final solution will be speed answers and good accuracy. That's it. What we need. Tell the truth.
Maybe you can suggest some tools or frameworks to use for pet projects, for home projects, where people can just try themselves to create something, some LLM, maybe that self-hosted LLM that use Rec.
Sure. For Rec, good choices for anyway. This is LangChain. I mean, about in the cloud, I today try to show these some technology which you can use in some background tools on or in the cloud. But most of the useful, this is here some link graph, very useful for home development and compare a lot of stuff. And you begin playing with LangChain and LangGraph. And after that, for database, you can connect it Milvus, for example. It's open source database. And for beginning, it will be enough. LangChain, Milvus, it's free and it's easy way for beginning. And after that, you can move into cloud. Again, from the cloud, you can using any cloud, but based on the practice, again, more popular in production now, Microsoft Azure. And for that case, AI search, you can research it. They have very good certificate. You can go in through this certificate or just research. They're making agent out of box using this prompt flow and using this Microsoft Copilot Studio. It's very powerful tools. Yeah, but you beginning from, if the home, you can begin from LangChain and Milvus.
Okay, got it. I think it was my last question. Yeah, thank you very much, Andrei, for your presentation. It was really interesting, a lot of new information. So thank you everyone for joining, asking questions. Yeah, if you like Andrei's talk, or maybe you don't like, yeah, don't forget to give him a badge and rate for his talk on the event page. Yeah, stay with us, stay connected, and see you on next meetup. Yeah, thank you, Andrei.
Thank you so much. Have a good journey for your researchment and have a nice day, everybody. See you.
Yeah, bye.